This is Group Deployment of Service Checks. Please welcome Mike Weber.
Group deployment of service checks is the result of a project I've been working on for a couple of years. So just by definition, what I'm trying to do with this is take logical groups or categories of service checks and allow you to deploy them all at once. For example, if you wanted to deploy OS metrics and you were looking for something in the area of memory, it would allow you to see all of the memory checks that are available, and you could evaluate and deploy all the memory checks that you wanted to deploy. This is actually a part of a much bigger project that I've been working on, and it's the results of the Nagios classes that I teach. When I teach Nagios classes, the first thing that I do in each of the classes to ask each student to tell me what are the problems that they face with Nagios? What are the things that don't work? What are they struggling with to implement? And I try to collect those and implement those in the class, but also take note of those to see kind of where organizations are at. At the top of the list consistently is that organizations that have large-scale deployments are pretty troubled about the scale that they have to do this with. When I started consulting because I wanted the classes to be real. I didn't want to tell students, hey, I've done this in the lab, it should work for you. And of course, it doesn't always work that way. And also in the consulting situations with the large-scale implementations, I could see that there are a lot of issues when you have lots of things to deploy. What it does is it creates large-scale deployment stress. And as a result, you make some very bad decisions. People are so focused on the fact that they have to do the implementation that they don't do the right groundwork in order to make it all work correctly. What they actually do is spend very little time, not enough time, in analysis. They don't analyze the service checks. For example, I see a lot of organizations that have service checks and everything's at 5 minutes. So when you look at that, the CPU that really matters to them more than anything else, they'll have it at 5 minutes. Maybe it should be at 3 minutes. The disk space that's not going to fill up in 5 minutes, they've got it at 5 minutes, and that could easily be at 60 minutes maybe. The OS version that's not going to change, but every 2 years they're monitoring every 5 minutes. That's the kind of stuff that wastes time, wastes resources, and just doesn't make sense. And that's because they spend so much time worried about the actual implementation that they haven't done the correct analysis. Most of the time, people do notification dead last. And the reason is they're afraid that they're going to throw a lot of errors out into their whole network, and that's because there hasn't been enough analysis. It makes sense to do the notification, the escalation right off the bat so you can test that just like you're testing everything else. But this lack of analysis and little emphasis on design causes companies to come back and have to rebuild things, redo things. And it's because they're focusing on the actual implementation too much. Because of that, I've been thinking about trying to make ways for organizations to speed up the implementation. So this is my dream project that I've been working on. It really has 3 parts. One, I want to be able to deploy the entire structure for Nagios. And this involves the service groups, or the services in groups that we'll be talking about, I'll be showing you today. It means pushing out the service templates, the host groups, the commands, the services, the notification, the escalation, pushing out this entire structure. Not all of the hosts at first, but pushing out the structure so they have this skeleton that they have thought through and organized and spent time with, and then bring in another script and deploy all of the hosts that fall into the host groups. The concept is this. When you place a host in the host group, because it's tied to a service template and all of the necessary services for that host group, it automatically populates that. So this concept that I have is to be able to roll out 300, 400, 500, 700 servers and all of the services in 15 minutes. The goal is to help organizations take away the fear of the deployment so you can spend the time in the actual analysis and design and evaluation stages that help you make those good decisions that you won't have to go back and fix things. Part of this, and I'm trying to create 20,000 service checks so that this is representative of Windows WMI, NCPA, NSClient, Linux, SNMP, NRDS, et cetera, each one of these categories with the proper service checks so that whatever you're doing, you can use a script or a wizard to deploy that information. And I want to provide a database that is searchable, so once it's deployed and you say, hey, listen, we need some other things, you can go to this database, you can search for a service check, you can find the definition, you see a description of how to install it, possibly see a video of how to install it, copy and paste of the script you can put on your server, and then a screenshot of how it all works. So, of course, it's a huge project, but at this point, I'm about 40% done, and so there's a lot of great possibilities for organizations to get this to work. There's 4 pieces to this puzzle. Create the code to deploy the structure. Now, actually, when we're talking about today is deploying this structure with these groups of service checks. And so that also is including, as you can see, service template, host groups, the commands, and the services themselves. So the structure is without the hosts. And then the second step is to create the code for deploying the hosts. If any of you were at the conference last year and came to the speech that I gave, that was the script that we did, that I talked about last year. That script worked. I used it in large organizations, and that script will deploy those hosts, and they'll get populated. So much of the work here is already done. Most of the first step and the second step are completed. And I'm working on inputting all these pre-configured checks for you so that you can have all of these options and get yourself going quickly. And ultimately, it will be a wizard for XI, a script for Nagios Core. So, what I'm trying to do is to cut your deployment time by 95%. A whole lot. Make it faster. Take that worry off of you about thinking and spending all your time in deployment when it should be in other areas of your situation. And to create efficient management. Now, there's absolutely no purpose in using a script that gets everything out there quickly, but creates a mess for you to work with later. So, you've probably heard this term before, rapid deployment, efficient management. They have to go together. It has to build the structure so that you can go to one service template and change the configuration for hundreds of services. You've got to make your life easier. And so using object inheritance is important in this whole structure. So here are the 5 strategies that I think that an organization should consider when they're looking at any kind of implementation. Analysis should take up the majority of your time. And when I'm talking about analysis, I'm talking about if you have a Linux server, you bring in your Linux experts and you say to them, okay, what should we check? What are the triggers? How often should we check? Where's the level where memory is a problem? And if you've got Oracle, bring in your Oracle experts and say, hey, this is what we're thinking about. What do you think about these checks? Do these make sense? Take all this information you can gather from your organization and put it all together so you can make good decisions about how you set up your Nagios implementation. Design. Design is really critical, of course. Everybody's network is a little bit different. Your topology, your firewalls, et cetera. What do you want to do? What can you do with the situation that you have? Evaluation is a stage where you set up a test. You have to test every server type you're going to use. If you're going to monitor Windows SQL servers, you got to have them set up. You got to hammer them. You got to test them. You got to make sure that it's going to work as you expect. And then rapid deployment and efficient management. These are areas that shouldn't take a lot of time. You should focus on those lower 3 layers. So, a little more specifically on analysis. And again, I'm trying to give you a picture of how this group deployment fits into the overall picture. Analysis. Are you going to be monitoring hardware? Well, then you're looking at S&MP probably. Are you going to be monitoring, is your network mostly virtual? Well, you've got those virtual hosts, but you also have to monitor those hosts that are creating the whole network infrastructure, the virtualization. Your network topology, the firewalls, what ports can you use? What options do you have? Where are your data centers? How are you going to connect all those connections? How is that all going to work? Your host types, Windows, Linux, are they production? Are they development? Are you going to notify the same way for production and development? Probably not. You need to make those distinctions as you set up and do your analysis. And all of those specific settings. It's a pain. I know it's a pain. And you're saying to yourself, this will take forever. But it's a whole lot faster than rebuilding 2 or 3 times. It does take a lot of time, but it does have a lot of value. Are you going to use active or passive? Why would you use passive? If you're going to use passive, have you figured out a way to train your staff so they understand passive? In the classes, I always say this time after time to drill it into people. Don't build anything you can't troubleshoot. It's going to break. You've got to figure it out. You've got to be able to relate this troubleshooting process to your staff. And so in your design, you've got to always think about the process of troubleshooting because that is going to be a necessary aspect of the whole thing. Where are you going to place Nagios? Is there going to be a Nagios in every data center? How are you going to see one pane of glass? Are you going to use Nagios Fusion? Are you going to use federated monitoring? What kind of resources do you need for your Nagios server? There's a lot of decisions that need to be made here. What can you do if you have to expand on those resources? How do you make changes? This is a massive curse for a big organization, and it has to be one of those decisions that you decide up front. Are we going to use Puppet? Or maybe we're going to use NRDS, because we're using NRDS, when that agent calls in, it also pulls down new configs in the plugins, so you don't have to touch those hosts again. But those are the decisions you have to make in the design. And you have to be careful with those decisions because they could come back and haunt you. Now, you're going to want to set up an evaluation. You're going to want to set up, like I said before, one host type of everything that you want to monitor. And you're going to want to set up those applications. Don't cheat yourself on that evaluation stage. Again, if you have a database, you've got to bring your database people in. If you have proprietary applications, bring those people in. Let them tell you what are the triggers. When do we just about know this thing is going to choke? And you can set your warning and critical states so that you can monitor those things effectively. You want an easier path? It just doesn't exist. Nagios is not magic. You're going to have to do some hard work. And so part of this whole issue is just coming to grips with this, because the larger the install you perform, the quicker your mistakes are going to show up. That's just the way it is. Those little things you can get away with, you can just about do any little stupid thing you want to in a small setup. but it's going to come back and haunt you if you have scale. The fourth stage in those strategies, the fourth strategy is rapid deployment. So deployment of templates, service checks, the structure is actually what I'm going to show you an example of today. So you can see that that's a part of this rapid deployment strategy. The deployment of the hosts into the correct host groups so that they get the service checks and the parent setting. Good grief, don't forget the parent setting, which 85% of the organizations that I see, and I see hundreds of them every year, have nothing set for parents. And they wonder why they get these storms of alerts because they haven't set up that relationship that Nagios wants to know about. So in rapid deployment, we're talking about that top option, setting up the groups of services you want and including all of the templates that create the structure. The efficiency is to create leverage. That's a great word. As an administrator, the goal is that you can go to one place and implement changes that will change many different services or hosts, whatever you want to change. I did a project for an organization and they had 400,000 service checks. And my job in that implementation was to try to detect ways that they could get better performance because they were really starting to drag on performance. It was a Nagios core. And one of the things that I discovered was that when you have a lot of config files, it really slows Nagios down. I took the config files and chopped out 60% of the stuff that was in the config files, and it speeded up their Nagios implementation by about 8%. It was a dramatic change. So what I'm trying to say is, if you have 1,000 servers and you run 1,000 wizards against those 1,000 servers, you know how many config files you have in your Nagios XI? I mean, you're just filling all of these config files. So creating leverage is important not only for your efficiency, but for how Nagios will actually run. I teach the 5-piece model. There's a lot of ways to do object inheritance, but I teach the 5-piece model simply because this is the simplest, it's a good place to start. You can modify it from there. So 5 pieces. You have a host, of course, and that host is attached to a host template. The host template for Windows OS sets all of those settings for all of the Windows servers. Then it's connected to a host group. So if you had a Windows server, it would be in the Windows OS host group, and that would populate all of those necessary memory, disk, CPU, all of those OS metrics. But that same host can be in multiple host groups. If it was a SQL server, you could put into the SQL host group as well, and that would automatically populate the SQL checks that you've already verified that you want to use. So by using host groups for both the actual hosts and the applications, you can set up your network infrastructure so that you can use this leverage to help you in monitoring and managing your network infrastructure. The service templates have all of the services attached to them so that you can go to that service template and you can make changes that will push through all of those services. Now, the service template is tied to the host group, so that's why if you drop it into the host group, it automatically populates those checks. This is kind of an outline of what happens. So you have a host group and you have a host template. That host is tied to both of those. The host template sets the check settings, all of those timings, who's going to get notified, and the miscellaneous settings. And of course, you have contacts and contact groups. The service template is tied to the host group. And the service template, again, is tied to all of those services. The service template has all of those settings for your check interval, et cetera, and all of the notification there as well. So this means that the services themselves don't have settings. Why? That's how you deal with your exceptions. So if you have a group of OS metrics, you've got memory and you've got CPU and you've got disk space, et cetera, and you say to yourself, hey, I've got it tied to a service template. The service template says it should check every 5 minutes, but I'd like to check CPU every 3 minutes. Using this method, then you can go to the actual service for CPU checks and put the 3 in there, and it overrides, because it's a local setting, the settings from the template. That allows you to work with exclusions. So my idea was to build a script that would be kind of a proof of concept to this. Now, as I've said before, I've already built the first script, sent it to my developers for taking hosts and putting them into host groups and populating them. Now, I'm not a developer. When I create scripts, I just try to create proof of concept, and I give it to my developers. They have a good laugh, and then they build it right. But at least the proof of concept gives you an idea of where I want to go. So these are group-prepared checks. I'm actually spending time evaluating these specific checks. I'm going to use, in this example, NCPA and Windows performance counters in what you'll see here. So again, these groups are logical groups, because you're going to say, hey, I want to check the CPU. What are the options that I have? What's the information that I could collect here? And it's also going to push out that efficient management. And it's going to be a script to be able to deploy that. The script is going to allow you to select the group you want. So if it's memory, or if it's IIS, or whatever group you would want to select. Now, in this example, using NCPA, we're going to add a token and an IP address. Now, one thing to understand, the script is to build the structure. So we're taking one IP address and installing one host for each type that you want. This is the structure. This isn't where you install all of the hosts. That comes in later. But you want to build the structure so that you can evaluate it, and you've got your situation ready to go. It's going to create the skeleton: host group, service template, services, commands, and definitions. In this script, because there's a lot of mystery about Windows performance counters, in the work I've done with performance counters, I've found at least 10,000. I don't know how many Windows performance counters there are. There could be 20,000. There could be 25. I don't know. But there are a lot of them. And if you go and try to research a lot of these performance counters, there's not a lot of information out there about them. Windows doesn't do a great job on some of these things. So I've tried to rewrite some of these definitions to help in that process. So the skeleton is this group deployment of service checks with the commands, the service templates, and the host groups. This is all a part of rapid deployment. So there's the script. These are just some basic directories that it has so that you can add things for checks, commands, definitions, host groups, et cetera, et cetera. So this is a part of the rapid deployment strategy. This is a way that you can get things rolling quickly. Eventually, this is where I want to go. Divide up different methods of monitoring Windows and Linux, and then start breaking it up into these groups. Event log filters. This is another area that's a great treasure for getting information, but somebody's got to do some work on it so you know what you want to set up and collect. And Linux, of course, all of the things that go with Linux as well. So the script is going to do these things that you see here. It's going to give you performance counter definitions, so you can select a group, and you'll see a definition for each one of the memory checks, so that you've got it collected in one place. You don't have to waste all your time roaming the internet trying to find those definitions. It creates a browser API access. So with NCPA, you can create links that you can drop into a browser, and it will give you the information about that server. So I've created a part of this script so that it will do that automatically for you, so that you can test out what you want to see, what kind of information is happening on that server. And then the active service check will go out, do the check, and automatically build graphing for that particular service check. And then passive checks. NCPA can be both active and passive. So the script will generate all of the passive checks. So it will, if you say, hey, I want to look at disk options, it will generate all those disk options, copy, paste into your Windows server, comes into XI in unconfigured objects, you click on it, it's installed, and you're done. So I'm just trying to make it easier for you to implement all of NCPA options with Windows performance counters. Now, you can take the wizards inside Nagios and you can modify them. And you could take the structure and modify those wizards to use the structure that you want. We've done that in class a couple times. The only problem with modifying the wizards is it's always nice to have the wizards as a backup for your staff if they needed to use those. And every time you update, of course, then you're going to have issues with those changes you've made. So we're not going to talk about the wizards and how to change those, but we'll talk about these others. So the perf counter definitions. These definitions are difficult at best. If any of you have been looking at those Windows performance counter definitions, some of them are pretty tough to understand. So we've tried to rewrite some of those while we've actually rewritten all of the ones that we're using. So here's an example, processor and processor time. Counter measures how much time the processor has been in productive time, et cetera, et cetera. So there's a definition of every one of these Windows performance counters. So in the script, you can, again, select what you want, go through the definitions. You have some idea of what you're doing. You can implement those, and then you can use them as you see fit. So here's the actual script. It's a bash shell script. So choosing to review the Windows performance counters, it gives you a list of all the groups. You can see how they're grouped: cache, job, object, net, adapter, et cetera, et cetera. So those are tried to make logical groups. You could change these around if you wanted to, but I tried to do things that would make sense that you would maybe want to implement. And then it will give you each one of those counters with the definitions so that you can review them. Now, these API access through NCPA, it sounds like an easy process, but you have to convert these all to ASCII to be able to do that. In other words, those spaces have to be a %20, et cetera, et cetera. So the script will do that for you. So what's going to happen is it's going to ask you a question, and then you answer a couple questions, and it's going to create all of those links that you can use in the browser. So you'll select the browser access. It will give you the groups that you can use. It's going to ask you an IP address, and then it's going to ask you for the token. So you add those, and then it builds the links that you can drop into any browser, and it will access your API with NCPA. So this is basically what it looks like. So it's an interesting way to test out what you've got going and try to make some decisions about how you want to modify what you're monitoring or what's important, what's not important. The active checks, like I said, have the built-in graphing, and it's also going to install all of the structure that is needed for that. So that, again, is your host groups, your service templates, the actual command, the script for the command, setting up the command definitions, and the services. So you select the active checks. It shows you the groupings. You select a host group that you want to use. So here, if you wanted to select a host group and you were going to implement IIS, for example, you would select IIS host group. so that you could drop your hosts into that group later and it would populate with all of the IIS checks that you wanted to perform. It's going to then ask you what services you want to deploy, what's the token you're using, and what service template. So if in your service template, of course, you can make modifications to your service template in the script however you wanted to set that up. All of your settings, your timing, everything that you're going to do there, you could have that all pre-configured the way that you wanted to use these particular checks for. And at the bottom, you can see what happens here is the script goes into Nagios XI, pulls out the host groups file, and puts it in the USR local Nagios etc import directory. That import directory, then you can make changes to those config files and then pull them back in. So all of these files go into that import directory and then are imported into Nagios and then implemented in that process. So use that import directory because that's how Nagios designed that to be used. At the bottom of the screen, you can see once it goes into the import directory, it runs that reconfigure script that Nagios has set up, and it pulls that in and puts it into the database, and you're all complete that way. There's the example of the graphing it builds ICMP. So there is the host group, so NCPA Perf hosts, you can call it whatever you want to. There are the service checks, they're all ready to go. Now they're not assigned to a host, they're all into Nagios XI, everything's set up, all of the structures ready for you to make decisions on which hosts get these checks. There's the service template, and you can see that the service template then is the thing that controls all the services in this host group. So it has the check interval, the retry interval, your check period, all of those types of settings. Your alert settings, who's going to get notified, how often, what's your notification period, all of those settings then are coming from the service template. And again, the service template is important because the services themselves are empty. If you have an exception, then you can go to the service to modify that service, use it as an exception. Because when you build in this object inheritance, you always want to think about exceptions because, of course, you'll have those. The passive performance counters, this is simply going to be a copy and paste. So you can drop it into the Windows server once you've installed that agent. So you'll select the passive option. It's going to allow you to choose the group that you want, and then it's going to build out. It's going to ask you what the token is, and then build all of those links. Again, they're modified for ASCII so that they'll work. You drop them into your Windows server, and immediately they start sending to your Nagios XI server. And they'll show up in unconfigured objects, and then you bring them in. So here they are. They've shown up in unconfigured objects. You click the little blue arrow. It asks you a couple of questions, and you're done. This is a simple way to bring in a lot of checks into your Nagios server using the passive checks. And there's the checks in place. And you can see by the green box there, the little green arrows, that it is a passive check. So that means it is different than an active check. So once again, if you're going to use passive, train your people to understand the difference between passive and active, and use some checks to make sure that those hosts are talking to your Nagios server so you don't get caught with the fact that the host may be down, but the check is always going to stay green. It's never going to change if that host is not talking to it. So you need to put some checks in there to verify that. So these 5 strategies, I think, are important strategies when you're looking at large-scale deployment. Analysis. Don't cheat yourself on analysis. Design. Focus on design and evaluate it in a small-scale situation so that you understand that it works. This is where you find out if you made mistakes in the evaluation stage. And so you don't want to shortcut that. And then if you can use scripts for rapid deployment and focus on efficient management, it's going to make your life easier and you will be a massive success with large-scale deployments. Any questions?
No questions? All right.
Hi, my name is Kanak. So assume that we have services it's doing for the operating system level. I have a template, and then I have some services I am doing some counters. Is there any way I can take the configuration report, I can verify it, what are the things belongs to template, and what are the things belongs to individual service configuration?
Yeah, so we've talked about this in one of the meetings earlier today and this is a dilemma. It really is a dilemma, and especially in Nagios XI, because there's no easy ways to tell what's connected to what. And I know that Nagios is going to try to solve that. They talked about a solution for that coming down the pipe. Currently, if you have a host or a service, there is a little blue icon in the Nagios XI that you can click and it will tell you about dependencies. That's the best that you can do right now. But that still is a little bit deceptive. One of the problems with object inheritance is if you start stacking service templates, for example, you'll have staff that will say, they'll look at one service template and say, well, this must be where everything's coming from. And they'll be wrong, because it's coming from another service template. And that is a problem. And again, if you don't want to build something that you can't troubleshoot. So that's why I try to teach it as simple as possible. You can still leverage it, but you don't have those kinds of mistakes. Not to say that chaining templates is wrong, it's not. But you have to be able to understand that. So to answer your question, right now, there's nothing that really shows that in a graphical way that would help you, unfortunately. But it is coming.
All right, thanks for that presentation. I totally agree with all that. I just wonder in your analysis phase, how do you decide between agents? You've got a whole variety right now, and
yeah, and and it's a great question, because it is a dilemma, and I think that's the right word. There are a lot of things that I could say about the agents, but part of your decision about your agents is who you're working with. Many of these organizations have a staff, and if you only have one person that understands passive checks, maybe not so great an option. And so that would eliminate some of those checks. Some of the checks have been around for a very long time. NRPE, NSClient's been around for a long time. But one of the things that is troubling about NSClient is that in the last couple versions, there have been changes that are quite a bit different in those couple of versions. Hopefully that won't happen going forward, but that would be a decision that I would be wondering about in terms of down the future, are you going to have to change configs on all your Windows hosts? So that could be an issue. The other issue to think about is it a binary or is it a script? Large scale, those scripts come back to haunt you time after time. So something like NRPE might be a better choice than NCPA simply because it's a binary and it's going to save you some resources on a Linux box. Firewalls, of course, are a decision that you're going to have to make. But a lot of it has to do with staff, and unfortunately, some of it has to do with politics. In a big organization, everybody deals with politics, and that can be a real struggle.
thanks.
Yeah.
Anybody else? All right. Thank you very much, Mike. Mike Weber, ladies and gentlemen.